Hello students. So in this class we want to explain some more different models of the limit problems. Here see the first question, limit extends to 0 root or 1 plus x minus 1 by x equal to 1 by 2. If you substitute directly x value 0 in this question, we get root 1 minus 1 0 by 0. This is called in indeterminate form. Okay. So now simplify this function. Simplify this function means rationalize the numerator. Rationalize the numerator. So limit extends to 0. Limit extends to 0. What is the rationalizing factor of the numerator? Root 1 plus x minus 1. Root 1 plus x minus 1 into root 1 plus x plus 1 divided by x into root 1 plus x plus 1. Okay. Root 1 plus x minus 1 into root 1 plus x plus 1 by x into root 1 plus x plus 1. This is equal to limit extends to 0 a minus b into a plus b, a square minus b square. So root over 1 plus x whole square minus 1 square divided by x into root over 1 plus x plus 1. Cancel square and root. This is equal to limit x tends to 0 1 plus x minus 1 by x into root over 1 plus x plus 1. Minus 1 plus 1 cancel, x cancel. So this is equal to limit x tends to 0 1 by root 1 plus 0 plus 1 equal to 1 by 1 plus 1 equal to 1 by 2. Okay, now here limit x tends to 0, limit x tends to 0, it is in the form of so cube root of 1 plus x. Cube root of 1 plus x can be written as 1 plus x whole to the power of 1 by 3 minus 1 minus x whole power 1 by 3. Okay. So we know that a cube minus b cube equal to a minus b into a square plus ab plus b square. Okay. So this is equal to a minus b equal to a cube minus b cube by a square plus ab plus b square. So that's why remember that it is in the form of a minus b. So just remember that this is a and this is b. This is a minus b. So this is equal to limit x tends to 0 a cube 1 plus x whole power 1 by 3 whole cube minus 1 minus x whole power 1 by 3 whole cube divided by x into a square 1 plus x whole power 2 by 3 plus ab 1 plus x whole power 1 by 3 into 1 minus x whole power 1 by 3 plus b square 1 minus x whole power 2 by 3. Okay. Now cancel these three values. This is equal to limit x tends to 0 1 plus x minus 1 minus x divided by x into 1 plus x whole power 2 by 3 plus 1 minus x square whole power 1 by 3. Okay. 1 plus x into 1 minus x plus 1 minus x whole power 2 by 3. Now minus 1 plus 1 cancel. Minus or minus x plus x plus x 2x. This is equal to limit x tends to 0 2x by x into 1 plus x whole power 2 by 3 plus 1 minus x square whole power 1 by 3 plus 1 minus x whole power 2 by 3. Okay, now cancel these two x values. This is equal to 2 by x0 1, x0 1 and x0 1. This is equal to 2 by 3. Okay, 1 plus 1 plus 1 3, 2 by 3. So the correct answer is 2 by 3. Write down. Show that limit x tends to a, x sin a minus a sin x by x minus a equal to sin a minus a cos a. So this is also very important question. So if you substitute directly x limit x tends to a sin a minus a sin a 0 by 0. This is an indeterminate form. So now limit x tends to a, so limit x tends to a, x sin a minus a sin x. Now plus a sin a minus a sin a. Just we have to write the terms. Plus a sin a minus a sin a divided by x minus a, divided by x minus a. This is equal to limit x tends to a, limit x tends to a. Now write the terms x sin a minus a sin a, x sin a minus a sin a, okay, minus, now plus a sin a minus a sin x, okay, divided by x minus a. This is equal to limit x tends to a. If you common the value of sin a, so we get sin a means x minus a into sin a plus minus a into sin x minus sin a into minus a into sin x minus sin a divided by x minus a, divided by x minus a. Now separate the values. Limit x tends to a, x minus a into sin a divided by x minus a cancel, minus a into limit x tends to a, sin x minus sin a, sin x minus sin a divided by x minus a into sin x minus sin a by x minus a. This is equal to sin a minus a into limit x tends to a, sin x minus sin a means 2 cos x plus a by 2 into sin x minus a by 2 divided by x minus a, okay, minus a into limit sin c minus sin d, 2 cos c plus d by 2 into sin c minus d by a. So this is equal to sin a minus a into, write the 2 before the value of the constant, limit x tends to a, cos of x plus a by 2, separate the limit, cos of x plus a by 2 into limit x tends to a, sin of x minus a by 2, sin of x minus a by 2 by, now write this value as x minus a by 2, okay. Now this is equal to sin a minus a into limit x tends to a, cos of a plus a by 2, cos of a plus a by 2 into, it is in the form of sin x by x, limit x tends to 0, sin x by x. This value is 1, this value is 1. Why? Because as x tends to a, x minus a tends to 0. This implies x minus a by 2 tends to 0. Okay, that's why this is into limit of x minus a by 2 tends to 0. Sin of x minus a by 2, sin of x minus a by 2 divided by x minus a by 2. Okay, like this. This is equal to sin a minus a into a plus a, 2a, 2 to cancel, a cos a into 1. This is equal to sin a minus a cos a. This is equal to sin a minus a cos a. Okay. This is the another question. Limit x tends to 0, sin of a plus bx minus sin of a minus bx by x. See, now we can solve this by using the CD, trigonometric CD formulas, because it is in the form of sin c minus sin d. So, limit this is equal to limit x tends to 0, sin of a plus bx minus sin of a minus bx divided by x. Okay. So, what is the formula of sin c minus sin d? So, sin c minus sin d equal to 2 cos c plus d by 2 into sin c minus d by 2. Okay. Sin c minus sin d equal to 2 cos c plus d by 2 into sin c minus d by 2. Now, this is equal to limit x tends to 0, sin c minus sin d, 2 cos c plus d by 2, a plus bx plus a minus bx by 2. Okay, 2 cos c plus d by 2 into sin c minus d by 2, sin c minus d by 2, a plus bx minus a minus bx by 2. Okay, 2 cos c plus d by 2 sin c minus d by 2 divided by x. So, this is equal to limit x tends to 0, 2 cos minus bx plus bx cancel. So, a plus a, 2a by 2 a into sin of we get plus a minus a cancel, minus of minus bx plus bx, 2bx by 2 bx divided by x. Now separate the limit value. This is equal to limit x tends to 0. This is equal to, so 2 cos a is constant, 2 cos a is constant into sin bx by x. Okay. So, this is equal to 2 cos a into, by we know the formula, limit x tends to 0, sin bx by x, we get the constant b. So, this is equal to 2 cos a into b, this is equal to 2b cos a, 2b cos a. Write down. Okay. Now, limit x tends to 0, cos ax minus cos bx by x square equal to b square minus a square by 2. Now, limit x tends to 0, cos ax minus divided by x square. Okay. It is in the form of cos c minus cos d. So, cos c minus cos d equal to minus 2 sin c plus d by 2 into sin c minus d by 2. Okay, cos c minus cos d equal to minus 2 sin c plus d by 2 sin c minus d by 2. Now by using this formula we can write limit x tends to 0. So limit x tends to 0 minus 2 sin c plus d by 2, that means ax plus bx by 2 into sin c minus d by 2 ax minus bx by 2 divided by x square. Okay, minus 2 sin c plus d by 2 into sin c minus d by 2 by x square. This is equal to minus 2 into limit x tends to 0 sin of a plus b by 2 into x divided by x into limit x tends to 0 sin of a minus b by 2 into x divided by x. Okay. Okay. This is equal to minus 2 into limit x tends to 0. It is in the form of sin ax by x. We know that limit x tends to 0. We know that limit x tends to 0 sin ax by x equal to a. This is also very important formula. So limit x tends to 0 sin ax by x equal to a. That's why here the value of a is this one only. This one only the value of a. This one is the value of a, and this one is the value of a. That's why minus 2 into sin ax by x a. That's why a plus b by 2 into here also a value is a minus b by 2. A minus b by 2. These two values are cancelled, equal to 1 by 2 minus 1 by 2. A plus b into a minus b. A square minus b square equal to 1 by 2 into b square minus a square. 1 by 2 into b square minus a square. Okay. Okay, students. See here. Now limit x tends to 0. Limit x tends to 0. First of all, substitute the value of tan dx and the value of cos dx in terms of tan x. We know that tan to x. We know that the formula of tan to x. Tan to x equal to 2 tan x by 1 minus tan square x. 2 tan x by 1 minus tan square x. And the cos to x equal to 1 minus tan square x divided by 1 plus tan square x. Okay. Cos to x equal to 1 minus tan square x by 1 plus tan square x. Now limit x into tan dx 2 tan x divided by 1 minus tan square x minus divided by 1 minus cos 2x means 1 minus tan square x divided by 1 plus tan square x whole square. 1 minus tan square x by 1 plus tan square x whole square. Equal to 2x tan x. 2x tan x minus 2x into, so minus 2x tan x. 2x tan x into 1 minus tan square x. 1 minus tan square x divided by 1 minus tan square x divided by 1 minus tan square x divided by So now let us take the LCM. So 1 plus tan square x minus 1 plus tan square x divided by 1 plus tan square x whole square. Okay. See 2x tan x minus 2x tan x into 1 minus tan square x by 1 plus tan square x minus 1 plus tan square x by 1 plus tan square x whole square. Now 2x tan x cancel. This is equal to limit x tends to 0 2x tan square x 2x tan square x like this, because minus 2x tan x into 1 minus 2x tan x plus 2x tan square x. So minus into minus plus 2x tan square x by 1 minus tan square x into minus 1 plus 1 cancel. Then we get 1 plus tan square x whole square by tan square x, tan power 4x, tan power 4x. Okay students, tan square x, tan square x, tan square x, tan 2 tan square x, 2 tan square x whole power 4. So this is 2 tan square x whole square mean 2 square 4. So 4 tan power 4x. So 1 plus tan square x whole square, tan square x plus tan square x, 2 tan square x whole square, 2 square 4 tan power 4x. Now tan square x, tan square x. Okay. So this is equal to limit x tends to 0. This is equal to limit x tends to 0. 1 plus tan square x whole square, 1 plus tan square x, limit x tends to 0, 1 plus tan square x whole square, and 2 by 4, we have only 1 by 2 into x by 1 minus tan square x, and this is also 1 minus limit x tends to 0, 1 by 1 minus tan square x, okay, into tan square x by x, tan square x by x. So 1 by tan square x by, so we have x, okay. So this value is x square. So that this is equal to 1 by 2, tan 0 1 plus 0 whole square, tan 0 0 1 into 1, this is equal to 1 by 2, okay. Right now. Okay, so these are some more different problems. Here, if you substitute directly x equal to 0, then we get 0 by 0. It is an indeterminate form. So that's why rationalize the denominator. Then simplification, after simplification of the function, we get the limit value. Now limit x tends to 0, limit x tends to 0, e power x minus 1 by under root 1 plus x minus 1. This is equal to limit x tends to 0, e power x minus 1 by root 1 plus x minus 1 into root 1 plus x plus 1 by root 1 plus x plus 1. Okay. This is equal to limit x tends to 0, e power x minus 1 into root over 1 plus x plus 1 by a minus b into a plus b. So this is equal to root over 1 plus x whole square minus 1 square. Cancel these two values, equal to limit x tends to 0, e power x minus 1. Okay, root over 1 plus x plus 1 divided by 1 plus x minus 1, plus 1 minus 1 cancel. This is equal to limit x tends to 0, e power x minus 1 by x into limit x tends to 0, root over 1 plus x plus 1. by using the some standard limits formula. This value is 1. If you substitute 1, root over substitute 0, 1 plus 0 plus 1 equal to 2. Now we are going to this one. If you substitute directly, then we get 0 by 0. This is an indeterminate form. So limit x tends to 0, limit x tends to 0, 3 power x minus 1 by root over 1 plus x minus 1. So now rationalize the denominator. This is equal to limit x tends to 0, 3 power x minus 1 into root over 1 plus x plus 1 divided by root over 1 plus x minus plus 1 into root over 1 plus x plus 1. Okay. Now this is equal to limit x tends to 0, 3 power x minus 1 into root over 1 plus x plus 1 divided by root over 1 plus x whole square minus 1 square. This value is minus 1. Minus 1 square. Square root cancel. This is equal to limit x tends to 0, 3 power x minus 1 by x into limit x tends to 0, root over 1 plus x plus 1. This value is log 3. So we know the formula. Limit x tends to 0, limit x tends to 0, a power x minus 1 by x equal to log a. By using this formula is log 3. This is equal to log 3 into, put x equal to 0, 1 plus 1, 2. So this value is 2 log 3. This value is 2 log 3. Okay, write down. Now, what are the indeterminate forms? So, I already explained in the indeterminate forms when the directly substitute limit value is 0 by 0. Indeterminate forms. Indeterminate forms. Indeterminate forms. Indeterminate forms are 0 by 0. Okay, infinitive by infinitive and infinitive into 0, infinitive minus infinitive, 1 power infinitive and infinitive power 0. Okay, so 4, 5, 6. These are the indeterminate forms. Okay, infinitive into power 0, 1 power infinitive, 0 power. These are the 0 power 0 also. 0 power 0. These are the indeterminate forms. Just remember 0 by 0, infinitive by infinitive, infinitive into 0, infinitive minus infinitive, 1 power infinitive, infinitive power 0 and 0 power 0. Now limits, now define the limits at infinity. Limits at infinity. Limits at infinity. Limits at infinity means let L comma H belongs to R. Let us take the two real numbers and define A equal to and capital A equal to H comma A. Let F be a function defined on this domain. Let F be a function. Let F be a function defined on the domain treated as the positive real number when H is positive on A. For each epsilon greater than 0, for each epsilon greater than 0, there exists delta greater than 0. There is delta greater than 0 such that so when x greater than delta implies modulus of f of x minus L is less than epsilon. Limits at infinity. So for any such that x greater than delta implies mod f of x minus L less than epsilon. This is the limits at infinity, and it is denoted by limit x tends to infinity f of x equal to L. Limits at infinity. This is the limit at infinity. At the same time, for each x belongs for each epsilon greater than 0, for each epsilon greater than 0, there exists delta greater than 0, there is delta greater than 0 such that x less than minus delta implies mod f of x minus L less than epsilon. So this is also limits at minus infinity, that is limit x tends to minus infinity f of x equal to L. Okay. So I want to give some examples. Limit x tends to infinity 1 by x equal to 0. So it's very important result. Limit x tends to infinity 1 by x equal to 0, and also limit x tends to minus infinity 1 by x also 0, and limit x tends to infinity 1 by x square equal to 0, and limit x tends to minus infinity 1 by x square also 0. Okay. So these are all the very important formulas. So let L, H belongs to R and A belongs to A equal to H to infinity. For each epsilon greater than 0, there is delta greater than 0 such that x greater than delta implies mod f of x minus L less than epsilon. Then limit x tends to infinity f of x equal to L. So L is the limit at infinity. At the same time, L is the infinity here. For this function, we have to define the domain A equal to minus infinity to L. Okay. For this function here, defined on a where A equal to minus infinity to L. Okay, students. So then limit x tends to minus infinity. This is the minus infinity. Okay. So as x tends to infinity or x tends to minus infinity, 1 by x becomes a, the finite value is 0. The finite value is 0. Write down. Let A belongs to R. And f be a function defined on deleted neighborhood of A. Then f of x set to be a limit, infinite limit at A. Then f of x set to be a infinite limit at A. If for each epsilon greater than 0, see the definition on the board. Let A belongs to R. And f be a function. Defined on deleted neighborhood of A. Defined on and f be a function defined on deleted neighborhood of A. So if for each epsilon greater than 0, there exists delta greater than 0. Such that so 0 less than mod x minus A less than delta implies f of x is greater than epsilon. And it is denoted by limit x tends to A, f of x equal to plus infinity. Limit x tends to A, f of x equal to plus infinitive. At the same time, for each epsilon greater than 0, for each epsilon greater than 0, there exists delta greater than 0, there exists delta greater than 0 such that 0 less than mod x minus a less than delta implies f of x less than minus epsilon. It is denoted by limit x tends to limit x tends to a, f of x equal to minus infinitive. Okay, students. So I want to write give some examples. Limit x tends to 0 plus 1 by x equal to plus infinitive, and limit x tends to 0 minus limit x tends to 0 minus 1 by x equal to minus infinitive, and limit x tends to 0 1 by x does not exist. Okay, and also limit x tends to 0 1 by x square also plus infinitive. Okay, students, write down these are the examples of infinite limits. So here I explained indeterminate forms, limits at infinity, and infinite limits. Quick. See, find the limits. Limit x tends to infinitive, x square plus 5x plus 2 by 2x square minus 5x plus 1. First question. Limit x tends to infinitive, x square plus 5x plus 2 by 2x square minus 5x plus 1. This is equal to limit x tends to infinitive. Now common the value of x square. See, this is the quadratic polynomial. So in quadratic, cubic, biquadratic, whatever it is polynomial, first common the highest power value. That's why then we get 1 plus 5x by x square plus 2 by x square divided by x square into 2 minus 5x by x square plus 1 by x square. Now this is equal to limit x tends to infinitive, cancel x square, 1 plus 5 by x, cancel these values, plus 2 by x square divided by limit x tends to infinitive. Now 2 minus 5 by x, 2 minus 5 by x plus 1 by x square equal to 1 plus 0 by 2 minus 0 plus 0. This is equal to 1 by 2. At the same time, second question also, limit x tends to infinitive. Now common the value of x square. Here highest power value is x square. That's why common the value of x square. Then we get 3 plus 4x by x square plus 5 by x cube divided by, here also common the value of x. Okay, now we are going to third question. So here also common the value of x cube into, so these are similar models. So x cube into 2 plus 3x by x cube minus 7 by x cube. Okay, x square cube cancel. We get 3 plus 0 by infinitive into 2 plus 0 minus 0. This is equal to 3 by infinitive, it becomes 0. Okay students, this question also same process. Okay, limit x tends to minus infinitive. Fourth question, limit x tends to minus infinitive. Again come the x square in numerator, we obtain 2 minus x by x square plus 3 by x square divided by x square into 1 minus 2x by x square plus 5 by x square. X square cancel. This is equal to limit x tends to minus infinitive. 2 minus 0 plus 0. This value is 2 minus 0 plus 0 divided by 1 minus 0 plus 0. 1 minus 0 plus 0. This is equal to 2. Okay, write down. So, these are the easiest questions, regular questions. So, limit x tends to 2 minus. Limit x tends to 2 minus. This is equal to limit x tends to 2 minus. That means x less than 2. When x less than 2, x minus 2 is less than 0. Okay. So, when x minus 2 less than 0, mod x minus 2 is minus of x minus 2. That's why minus of x minus 2 by x minus 2. These two values are cancelled. The constant limit is minus 1. Limit x tends to 2 plus. So, limit x tends to 2 plus means x greater than 2. X greater than 2 means x minus 2 is greater than 0. When x minus 2 is greater than 0, mod x minus 2 is x minus 2. That's why x minus 2 by x minus 2. Cancel these two values, we get 1 constant limit. Here x tends to 0 plus. X tends to 0 plus means x is positive. When x is positive, mod x is x. That's why 2 limit x tends to 0 plus, limit x tends to 0 plus 2 into x by x plus x plus 1. Now cancel these two values, equal to 2 plus 0 plus 1 equal to 3. Now when x tends to plus infinitive, that means positive real line, x lies in the positive real line. So x positive, when x positive, mod x equal to x. This is equal to limit x tends to infinitive 8x plus 3x divided by 3x minus 2x. This is equal to limit x tends to infinitive 8x plus 3x, 11x by x. Cancel these values is 11. Now we are going to when x tends to 2 plus. So when x tends to 2 plus means 0, 1, 2, 3, minus 1, minus 2. X lies in this here. When x lies in 2 in between 2 to 3, the greatest integer function integral part of x is before integer. You should take only before integer. That's why this is equal to limit x tends to 2 plus integral part of x plus limit x tends to 2 plus x. So first of all simplify this value. When x tends to 2 plus integral part of x equal to 2, that's why this is equal to limit x tends to 2 plus 2 plus limit x tends to 2 plus x. This is equal to 2 plus 2 equal to 4. Directly substitute the value of x. In place of x is 2. Now here also this is equal to limit x tends to 2 minus integral part of x plus limit x tends to 2 minus limit x tends to 2 minus x. This is equal to here x less than 2. X less than 2 means here x lies is here. X lies here. What is the before integer? 1. That's why limit x tends to 2 minus value is 1 and limit x tends to 2 minus x. 1 plus 2 equal to 3. Here remember that limit x tends to 2 minus means not minus 2. It represents the left limit of f of x at 2. Okay, right down.